Welcome to my video lecture based on Electrical Machine 2, paper code PCEE 501. Today's topic is speed control of three-phase induction motor. Myself, Romrum Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrasur Institute of Technology and Sports Complex. This institute is under JIS Group, and formerly this institute was known as Dr. Sudhir Chandrasur Degree Engineering College. In my last lecture, I have discussed about speed control of three-phase induction motor and what are the methods basically adapted for speed controls. That part I have been discussed, and the only part I have mentioned or discussed in my last lecture, that is the pole changing method. The remaining methods of speed control of three-phase induction motor we will discuss in this lecture. In all the methods like pole changing method or variable voltage variable frequency method or stator voltage control method, all these three methods can be applicable for both squirrel cage type and as well as slip ring type induction motor, but the rotor resistance control method is only applicable for slip ring type motor, and in cage rotors or squirrel cage type induction motor, the rotor resistance control method cannot be adapted because there is no provision in squirrel cage type motor to add external resistance, which is the main advantage of slip ring induction motor. Now we will see what are the methods or remaining methods of speed control of three-phase induction motor. So here we will mainly discuss on the speed control of three-phase induction motor by pole changing method, and that part I have already discussed in my last lecture. So in this lecture we will mainly begin with the speed control of three-phase induction motor by using rotor resistance control method and variable voltage variable frequency method, stator voltage control method, and all of this. So stator voltage control method of three-phase induction motor. Let us start with that. The speed of a three-phase induction motor can be varied by varying the supply voltage, and the equation which we have already developed previously, the equation of torque, that means tau equals to k, this will be k s e2 square r2 divided by r2 square plus a square x2 square, and these things are basically written with the stator voltage control method. And in this equation we can see that the developed torque is directly proportional with voltage square. That means it is square of the supply voltage. Shows, and the equation shows that the slip at maximum torque is independent of the supply voltage, and the variation of supply voltage does not alter the synchronous speed also. And the torque speed characteristics of three-phase induction motor by varying supply voltage is shown in this figure. The figure also shows the torque speed characteristics of fan load. Now the speed control is obtained by varying the supply voltage until the torque required by the load is developed at desired speed. The torque developed is proportional to the square of the supply voltage and the current is proportional to the voltage. Therefore, as voltage is reduced to reduce the speed for the same current, the torque developed by the motor is reduced. Consequently, this method is suitable for application where load torque decreases with speed, as in the case of fan load. So, so we can say that basically this method is applicable for fan load purpose. This is fan load type speed control method of three-phase induction motor. Next method is our variable frequency control. In variable frequency control method, we can see that the synchronous speed of induction motor is given by n is equals to 120 f by p. The synchronous speed, therefore the speed of the motor can be controlled by varying the supply frequency. The EMF induced in the stator of the induction motor is given by E1 equals to 4.44 kWf5T1. So we can see that the EMF equation of three-phase induction motor is E1 equals to 4.44 kWf phi mt1. So from here we can understand that therefore the supply frequency is changed and E1 will also change to maintain the same air gap flux. If the stator voltage drop is neglected, the terminal voltage V1 is equal to E1. In order to avoid the saturation and minimize the losses, motor is operated at rated air gap flux by varying the terminal voltage with frequency so as to maintain the V by F ratio constant at the value. This type of control is known as constant voltage per hertz. Thus, the speed control of an induction motor using variable frequency supply requires a variable voltage power source. The variable frequency supply is generally obtained by following converters like voltage source inverter, current source inverter or cycloconverter. These are the three main converters are there which can vary the frequency of supply. An inverter converts a fixed voltage DC to a fixed or variable voltage AC with variable frequency. An inverter converts a fixed voltage DC or a variable voltage DC to a voltage AC with variable frequency. A cycloconverter converts a fixed voltage and fixed frequency AC to a variable voltage and variable frequency AC. The variable frequency control allows good running and transient performance to be obtained from a cage induction motor. Cycloconverter control induction motor drive is suitable only for large power drives and to get low speeds. So definitely this is the most important method of speed control of three-phase induction motor. And we can understand that by using this method, a wide range of speed control is possible. Very low speed to higher speed of three-phase induction motor can be varied by using this variable voltage and variable frequency method. And here we can use different kinds of power electronics converter for changing the frequency as well as voltage simultaneously. Our next method is rotor resistance method, and this method is mainly applicable for slip ring type induction motor. The speed of wound induction motor or slip ring induction motor can be controlled by connecting external resistance in the rotor circuit. Connecting external resistance in the rotor circuit through slip rings. This method is not applicable to cage rotors, not applicable to cage rotors or cage motors. The torque slip curves for the various values of the resistance we have already shown in the lecture of torque speed characteristics. There we have shown that with variation of rotor resistance, that's how the torque can be varied. The torque speed curves are shown on that figure. It is seen that although the maximum torque is independent of rotor resistance, yet the exact location of Taumax is independent on it. Greater the value of R2, greater the value of slip at which the maximum torque occurs. It is also seen that as the rotor resistance is increased, the pull-out speed of the motor decreases, but the maximum torque remains constant. Therefore, by this method, control is provided from rated speed to lower speed. This method of speed control is very simple, and it is possible to have large starting torque and low starting current and large pull-out torque at same values of slip. So here we can see that this type of speed control is very simple, and it is possible to have large starting torque, low starting current with large pull-out torque at small values of slip. So this is very effective method of speed control in case of three-phase induction motor of slip ring type. The major disadvantage of rotor resistance control method is that the efficiency is low due to additional losses in resistors connected in the rotor circuit. The efficiency is greatly reduced at low speed because of higher slips. Because of low cost and high torque capability at low speeds, this method is used in cranes, Ward-Leonard drives, and other intermediate load applications. This method can also be used in fan or pump drives, where speed variation over a small range near the top speed is required. So, although this method is very helpful and important for slip ring type induction motor, but this method has definitely some disadvantage, and the disadvantage is the efficiency of this method is low due to the additional losses connected due to extra resistances. The efficiency is greatly reduced at low speeds because of higher slip. And because of low cost and high torque capability at low speeds, this method used in cranes, Ward-Leonard drives, and other intermediate load applications. And this method can also be used in fan or pump drives where speed variation over a small range near the top speed is required. So to recover from this um, low efficiency problem of rotor resistance control method, there is another method is there, that is slip power recovery scheme is also there, so that we can use the power which is lost in these external resistances, and that slip power can be recovered. That scheme is also there. for increasing this efficiency reduction problem. So that is up to for speed control of three-phase induction motor. I have just briefly discussed about these methods of speed control of three-phase induction motor. And among these, the most important one is variable voltage and variable frequency method. And you have to remember that the stator voltage control method is for fan load purpose, and pole changing method is generally used for squirrel cage type motor, and that is the oldest method of speed control of three-phase induction motor. And for larger industrial uses, we are mainly using variable voltage, variable frequency method. And rotor resistance control is most cheapest method, and generally it is used for where the speed variation range is quite less, and efficiency will be low in this case, but the method is also very cheap, and the starting current can be simultaneously reduced with this method. I have taken all this lecture from the book of Aspa of Electrical Machines. For advanced studies, you can go to the book of Nagrat Kothari Electrical Machines or Abhijit Chakraborty of Electrical Machines. You can also follow the book of Koso for your knowledge enhancement. The Bhimra book is also good. So, not much more for today's class. Thank you all for listening my lecture.